Hi, this is Colin Melia, and I'm here to talk to you about getting started with DevOps. I'm a Microsoft Regional Director. I'm also a Microsoft MVP for Windows development. So while that might not sound like it's directly related to DevOps, actually a lot of people in IT, developers and IT pros, are now doing DevOps of some kind. So you might already be practicing DevOps. For example, do you use unit tests in your application development? Do you have tools for deploying the code that you write to the cloud? Do you have a version release approval process? Do you track application usage? Or finally, do you have a process for establishing that a system is designed and continuously able to operate the way that you intended it to work? If you answered yes to any of the above questions, then you're probably already using DevOps. You may be doing it manually, and the next step for you might be to automate that process, or maybe to do some of the other practices that I'll talk about in this session. So what really is DevOps? Essentially, you need people, you need some practices, and you need some tools. You need the people because everybody in your organization has to be on board with the process. Otherwise, what you're doing may not be transfer over and the value may not be created throughout the organization. You need some practices, and we're going to talk about 7 key practices that are quite common in DevOps. And you also need some tools. We'll be using Visual Studio Team Services in this session, but we'll also point out the fact that you can use many other tools and integrate with Visual Studio Team Services, and your application may be built on many different kinds of frameworks. So let's dive into those 7 practices. We have infrastructure as code. And this is really about being able to automate or codify the infrastructure you need to deliver a solution and use that in an automated way. We have continuous integration, or CI, probably one of the most popular DevOps practices, and you may be using this one already. We also have continuous deployment. Sometimes this is confused with continuous delivery. You might think of continuous delivery as actually using several practices together. Continuous deployment gets a piece of code that we've built or a successful build out to the next step. Automated testing is often used to make sure that what we've actually built or a package of software we've built actually passes specific tests in terms of load or UI. Then we have release management, which is the process of packaging together all the assets we have, including maybe documentation and user manuals, and releasing that in a controlled fashion, often requiring certain approval from certain people that are actually operating under a specific role. Once the application is out in the wild, we have application performance monitoring and management to see if our application is actually performing and doing the things it's supposed to be doing. And finally, there's configuration management. Is the system performing to its specifications as we build it and in the long run? You can find out more about the definitions at David's blog here. So let's look at some of these in more detail and see how they're used with Visual Studio Team Services and Visual Studio. First, we'll look at infrastructure as code. The tools and systems you have might have the ability to manage a deployment or configuration of a system. By that I mean you might have a JSON file or an XML file that defines how your deployment should look, how many servers you have. You might want to just be able to take that configuration file, run a command line, and have that translate into an actual instantiation of the servers you need and the database you need running in the cloud. Doing this means we have a consistent approach for an environment. If you do something in development, it can be reproduced in production just by passing across that JSON file. Also, because it's just a file, maybe a JSON file, you can actually version it. And you can automate the process of the whole thing, and you get a lot of consistency if you do that. So here I am in Visual Studio, and I have this simple voting application. I'll just run it up. It's an ASP.NET application. There we go. It's just a simple application and it's used for doing live voting. What the application actually does isn't really relevant to this session. It's just that we have an application that we can deploy. If you're building for mobile application development, then you're practicing effectively mobile DevOps, and you might have an application that you're deploying to mobile platforms rather than a web application to the cloud. Although the mobile application may have a web component, of course. So that's a simple application. To start practicing DevOps using Visual Studio Team Services, we actually need to get this thing into the cloud and stored under source control. So let's take a look at Visual Studio Team Services. I'm able to set up an account for free and have 5 people work on it without any further cost. And in fact, anybody who has an MSDN license can also be added on, and that doesn't count as one of the 5. So here I've already created a project under an account, and this one's called Techdays Online DevOps 1. What I did next is I went under code, and there was originally no code here at all. And I just went to clone, and I clicked clone in Visual Studio. That opened Visual Studio, and then what I did is I actually copied the code of the sample application into the directory that was created, and then I did a push or a single git commit into the repository. And then the code's now here and we can see it. So here all we've done is put the code into the cloud. We haven't actually deployed the application to the cloud at this point. So this might be quite familiar to you in terms of having a Git repository. And in fact, to use the system of Visual Studio Team Services, we don't necessarily even have to be using Visual Studio Team Services for the source repo. We could be using Bitbucket or GitHub, for example. In order to get this code running in the cloud, we need an environment in the cloud. So we're going to use Microsoft Azure to host our application. Now, I could go into the portal, which I also have open in another browser window, and we'll get to that soon. But what I want to do is I want to automatically provision a known environment to deploy this application. So if I go here under deploy, you'll see that already under source control, I actually have a file for my simple voting app called template.json. This file defines the environment I need to run my application successfully. Again, this allows me to reproduce what I'm doing in development potentially in production, or of course you can make slight variations on this as appropriate for the scale of deployment. Pretty much everything that runs in Azure can be actually defined in these files. So the next thing I'll do is bring up PowerShell. I've already logged into my Azure account, so I ran a commandlet that allowed me to connect to Azure. In fact, I actually went and installed the Azure RM commandlets or Resource Manager commandlets already into PowerShell. So I've logged into my account, so in this window, it already has the context of an account. So in my PowerShell window, I can just do this command here. And off we go. I'll say, yes, I'll trust this. And it's going to go out to the cloud, use a certain subscription ID that's just for this demo, and it's going to start deploying the specific or instantiating the specific Azure resources I need to be able to host my application. It'll only take a few seconds to do this. The point is it can all be done programmatically. It's done through REST APIs and allows me to provision in a few minutes. There we go, already finished. So now if I go to the portal and take a look at my resource groups, I'll see this resource group has been defined. Just scroll over and have a look. So you'll see there's a voting app service plan and an app service for web applications already running inside there. So this was provisioned just by running that PowerShell commandlet. So now we have somewhere we can actually publish our application. we've effectively done infrastructure as code. So let's move on to continuous integration. Again, something you might be doing already. With continuous integration, we effectively want to get a new build automatically happening upon code check-in. We'd also like to be able to have some unit tests run and show if those unit tests were successful. That way, if somebody puts in some code that potentially breaks the build, we'll know about it before it goes any further. And effectively, what we'll get is known good builds. Or if maybe perhaps the last known good build. If the one breaks, we can go back and see what has changed. And they're known because we can define them against a specific build and a specific commit and see which code went in. So now I'll go back to Visual Studio Team Services. And now I'm going to go to Build and Release. So here you see I have all definitions, or just mine, and there's already a definition here, and you can see that it already succeeded when I tested it earlier. If I wanted a new definition, I could click New. In this case, I went to Empty and click Next. And you can see I specifically selected the code repo that I wanted to use. You can see that GitHub is listed here, and the other repositories I could potentially use, and then I pick a specific branch. Let's go ahead and edit this one. So we'll go into it, and we'll click Edit. You'll see here there are a number of build steps that happen when this build is executed. I could add additional steps here, which is what I used when I originally created it. So the first thing we do is we do a restore on Visual Studio to get all the NuGet packages. Kind of makes sense. Then we actually do a build on the solution with some specific arguments we want to use. Notice that we have some variables here that also need to be defined. We're using Visual Studio 2015, and of course there are other versions available. Next, we actually do unit tests. So it searches using this pattern to find the ones we want to actually execute. And we can decide here whether we want to continue or not based on those test results. We also say we want to publish the PDBs. And finally, we actually take those artifacts and put them into a specific directory on the build server. If we take a look at variables, you'll see that we actually defined a build configuration of release and a platform of any CPU. And we check some boxes over here that says when we actually do a build, we can actually change those or specify those specifically each time we do a build. Importantly, under triggers, you'll notice that I checked continuous integration. So basically, every time there's a check-in under master, we're going to do a new build automatically. So there's our continuous integration. Take a look at that batch changes checkbox there. That's currently actually set. Now, if we were to uncheck that, we get a different behavior. So now imagine that a build is already in progress and that build is going along and another check-in comes in while that build is happening. So what would happen is when the current build is finished, it would pick up that next check-in and do another build. But let's say that there are two check-ins that happen while the current build is running. Then the choices might be actually queue up and do 2 additional builds for those 2 extra check-ins, so we'd have a total of 3 builds. Or we can batch them together. So when we batch them together, it'll just say, okay, there were 2 check-ins, never mind doing one for each individual check-in, we'll just do a batch I'll batch those two check-ins together, and then we'll actually just do one build against those. So that's what the batch is for. Imagine you have lots of builds coming in. Imagine that your builds take, maybe 15, 20, 30 minutes, especially if there's some native code compilation going on. So you might not want to just drag out builds that could go on all day if they just go back to back. So that's what batch changes is about. We also can have a history of things we've done, or we can actually just queue up a build and run it right now if we wanted to. So there we have our continuous integration set up. Next, we'll go on to continuous deployment. This always happens after you've done continuous integration, and it allows us to deploy a known good build. So we know it's good because we can have tests and they have to pass for it to continue, or we can specify it that way. And we know what's in it because we know the git commit that was used for the actual build, so we know all the commits that went into it. We can send this to one of many environments. We could put this right into production cloud release if we really wanted to, or we can send it to a QA or a staging environment as we think is appropriate. So let's see what that looks like. So I'm actually going to build this step manually. So we're already under build and release. We'll go to releases. And we'll do new definition. And we'll pick empty and click next. So here we say, where do those artifacts come from that we actually want to release? And we're picking our build that we've done before. So there's the build, and there's the build definition we have already in there. Notice that we could actually pick something like Jenkins instead. So we actually want to specify continuous deployment. This means that once a build is complete, it will go on and go into the release and get released. That's all good, so we'll click create. So we'll just go in here and we'll say this is going to be production, because we're going to skip a few steps in our case. And we'll go up here and edit, and we'll call this voting app CD. Now we're going to add some tasks. You can see there are a variety of things available. If you actually look around this, you'll actually find connections to other capabilities and platforms and vendors as well. For example, there's some good Gradle and Grunt and Gulp there for you. So I'll go to deploy, and I'll pick the Azure App Service Deploy, and I'll add one of those in. And I can click around and add other things. One of the other things I could do is I could go here and do cloud-based load test. Or if I'm doing mobile DevOps, I could actually go and do a Xamarin Test Cloud run and make sure that my app runs well on numerous devices all at the same time, testing in parallel in that cloud system that's available. So I'll just stick with that for now and click close. I'll go and select my subscription there. I already have that connection set up. And we'll go down here and look for the service name, which is this one right here. Let's go in here. That's already set for us. So we're going to use web deploy for the actual publishing. And then in here, we're going to use a specific parameter that we'll define in a second, or rather a variable. So I'll just pop back to my portal. I'll click on my web app, which of course is currently empty. There's nothing deployed to it right now. So here you'll find the actual URL. If we click on this, it would be blank at the moment. So we're going to copy that. We'll go back. Then here, we're going to go to configure variables. I'm going to paste that in there. And this will be specifically set to web app URL. So that's all nice and neat and tidy rather than having a specific thing pasted or hard-coded down there. Check here under artifacts. Already got something set up, that's good. If we click link, we can see that's already there. Go to the triggers tab, and you'll see that continuous deployment is triggered when we actually have some source artifacts coming in from the build, which is the voting app CI build for continuous integration. We could also be specific about the branch if we wanted to. So we've got all of that in place, so we'll click Save. So now we have that in place. What we'll actually do is we'll go up to the builds. Go into voting app CI. We'll see there's currently a record of having 2 builds there before, and we'll queue a new build. You see I could set these parameters if I had to. It's all ready to go. Let's just click OK. That's going to start running, and you can get a lot of detail coming through here about what's actually happening, and we'll come back to it in a minute. So automated testing. You see where we could have actually put that in just a second ago. This is obviously for testing of a build that's actually being produced. So normally this can happen during the release part. So we might do something like a load test, or we might do a UI test, for example, with the Xamarin Test Cloud, where you take your application, it's deployed all the way into cloud, and it's run on potentially hundreds of devices, different makes and models you can select, and you run that process, and then you get back the results of if anything went wrong. And if something did, you get to see kind of recording or screenshots of what actually happened on those devices and the set of steps that you actually designed to happen for the UI testing itself. Now, you could do user acceptance testing, whereby somebody gets hold of that build, does something with it, and then you have a process of saying, yes, it passed. Obviously, that could slow things down, so automated is better. One of the options that we didn't really discuss is you could actually have this deployed to test users. So you could use something like Hockey App, if it's a mobile application, to deploy the application to Hockey App, and then that could automatically signal to your beta users or beta test users that a new version is available and they can go and try it. You could also then actually have a means of providing feedback, and that could actually come back into the test cycle in terms of whether things are as another test phase that you need to get through in order for your application to be considered ready for on the next stage of release. You then have release management. Think of a release as natural decision to take to market or take to some specific production environment the application, or you might actually just be releasing to the next stage, so staging. Often it might be a packaging of assets and everything else that goes together. And this again may be multi-stage with approvals. And this might involve different roles. So people might connect to Visual Studio Team Services, for example, who have specific roles and specific permissions to do things like sign off on specific artifacts. There's a lot of flexibility in what you can build in here. Obviously, continuous deployment and continuous integration are the things that people tend to do most, but release management can get very important when you have multiple versions, maybe you're white labeling products, all that kind of stuff. Then another practice is application performance monitoring and management. Here, what you might be doing is logging the application's health. Now, for example, again, we could use Hockey App, where we add some extra lines of code in the initialization of our application for a mobile application. And in that case, all the information gets logged to Hockey App if there's a crash. We basically get a crash dump, it's uploaded, and we get to see information that helps us debug the application. Or there may be some key issues that you want to be alerted to, like, hey, there's a lot of crashes today based on the number of people using the application. Or you just might want to see how many people are actually using the application today, and you can get that kind of thing out of Hockey App with maybe 1 or 2 lines of code added to a mobile application. And of course, you might want to actually track other use of your application. So if a specific feature is used, that information gets logged. This is all part of the DevOps cycle. And those things might provide actionable insights like what are people actually using, where is it going wrong, why aren't people using this feature? Maybe there's data you can get out of that that's particularly useful. And the final one is configuration management. This is a bit harder to pin down, but essentially you're going to establish and maintain certain system performance, features, and attributes of your system. And these are going to be based on what you originally had as requirements when you built the system, what you actually designed, and any operational feedback that's coming back to you. And so you want to make sure that the system is actually doing what it's supposed to do when it's first released, and that it continues to do that kind of thing. So it would be nice, for example, if this could be declared or codified. Like you could say there's a certain uptime we have to have. There's a certain number of transactions per second if there's a database involved. These are all things that you might codify in some way. And there are some tools that allow you to do that and declare that. And then you can have your whole system almost defined in terms of requirements. And then you publish that and the tool makes it happen. Obviously, it doesn't write the code for you quite yet, but it can do a lot of things that you then don't have to worry about in the operational part of the DevOps lifecycle. There are other DevOps practicing as well. There's more advanced monitoring you can do with your application, and you could get down really into the weeds about what your application is doing. There's capacity management, where you might do automatic scaling, and Azure actually has some of those features where you can scale up and scale down. And capacity management is also a process of predicting what might happen as well. Then you have feature flags. With feature flags, you can decide or even have code that's in there and have these things selectively turned on and or off. And that can feed back into your DevOps cycle as well. Then you have self-service environments where users can actually activate and enable things and provision things on their own. That obviously happens quite a lot with SaaS type solutions now. Automated recovery is something that you might want to establish as well. And then there's these other ones, these hypothesis-driven development DevOps practices, where you might actually do some sort of curious, risky testing in production. You might deliberately put faults into the system to try and establish whether your system reacts correctly. There's other usage monitoring and telemetry you can do. We've kind of covered that already when we talked about Hockey App. And you may do A/B testing where you deliberately give some users or some servers certain capabilities and you actually see what the effect of that is, either in terms of the performance of the system or just in terms of the usability of the system and what users end up using after all of that. So in terms of the applications, especially from a web point of view, that you might put through the DevOps process, the obvious one is a custom one, which is one you build yourself. There are these other ones like Apprenda, WordPress, Joomla, Drupal, or Cloud Foundry, which you might use. In fact, those are quite easy to provision on top of Azure in a few clicks as well. Those might still be all built on different app platforms, whether it's ASP.NET, Node.js, Python, Java, PHP, or Ruby. So the DevOps process and how you integrate and build, it could apply to any of these frameworks. You saw the build process for it was an ASP.NET or a .NET application. It could be another platform's application. You could have it go out and build something on a Linux box and still come back and tie into the whole process of DevOps on VSTS. You could be using Xamarin, and you could be building for Android and iOS. You can actually use cloud services that will build your iOS application and come back and then throw that out to the Xamarin test cloud and then keep going. So it doesn't have to be specifically a Windows platform you're targeting or a framework. You can have different middleware or different databases that you could be involved. There could be a provisioning process whereby when you release your application, it does a migration on your database. It's an important consideration. The whole thing could be running on Windows. It could be on FreeBSD, Linux, or Red Hat, or a Docker container running on Windows or Linux, for example. So all that stuff can be provisioned as part of release. Or like I said, you can go and build something on Linux and just come back and carry on in the process in VSTS. You also saw some points where you could actually be integrating with other systems. Your source could come from SVN or GitHub or Bitbucket or VSTS itself, or you could be using Jira in some way for task integration, and you saw the option of using Jenkins for doing the build. So it's not an all or nothing in terms of what vendor you use, but VSTS does a very nice job of tying it all together. For management purposes, and when we talk about that last DevOps practice, there are other products out there like Puppet Labs and Chef, Ansible, and Apache Mesos, which are great tools you could start looking at for doing some of that configuration management. So let's pop back now and see how we did. So here you can see the build that happened. I'll just scroll up to here. You can actually see it pulls out all of the files. It does its NuGet package restore. It does the build, and it does the tests. You can see the test results. It says 6 pass, 6 fail, and failed 0, skipped 0. We also then started doing our publishing. We published our artifacts, and we did the upload. So you can see we've got a nice checkbox here. If we just go back out to builds again, go into voting app CI. You see we now have 3 builds, so this is completely exactly how it was run. Let's go to number 3. What I want you to notice is that we get the details of when it was run, quite recently, and we see everything checked off nicely. We get to see the test results. So you get this detail here, and we could go into a detailed report. Let's get that detailed report so we could drill in there and see what happened with our tests. We can even see things like code coverage. And then you'll also notice there's a deployment. If I come back too soon, this would have said in progress. So production was actually released. There's release 1. So we'll go to production. Remember, we renamed it to be called production. So let's click on here and see what that has in it. You'll see some of that approval stuff we could have had there. This was actually automated. And you'll see that release 1 actually occurred. So we could do multiple releases into this slot or definition. And here you can see it was actually released. All good. And the point is the whole thing went through automatically. We did continuous integration. Well, we didn't do continuous integration. I manually queued it. But if I'd checked in some code, we would have had CI. And then we went and did the continuous deployment because we went and did the deployment as well. And we could have had some cloud tests there as well. So now if I go click on this, it's going to spin up our website that's hosted on Azure. And there's that same application I showed you at the beginning, kind of ready to be used, deployed on Azure. And the whole thing happened automatically. So there are some resources that you should probably go take a look at if either you haven't used DevOps before or you have and you just want to keep up to date and see what's going on. And some of these things are really useful to get into. First of all, the definitions. Um, I pointed you at the beginning to this blog post that you can go and read. That's kind of very useful as a starting point to get into it. And then once you've read the text descriptions and been to Wikipedia and been to Microsoft links and all this kind of stuff, go and start watch some of the shows on Channel 9. The DevOps fundamentals ones will tell you all about the practices and kind of get you up to scratch with how the products interoperate. And then go and see DevOps Dimensions, which is more magazine style show. Then check out DevOps Dimension / Mobile DevOps and see what the perspective is for mobile DevOps. You know, a lot of stuff that happens, you've seen here, the demo was for web application. And of course, people build applications for desktop and for mobile as well. And a lot happens with mobile DevOps in terms of people using it and all the testing you need to do, especially with Xamarin Test Cloud. It really helps with that for iOS and Android. And of course, you can also build for Windows 10. Xamarin is also kind of branching out to the Tizen operating system on Samsung TVs. So it's very important to understand that, you know, DevOps and the need to keep tracking of releases and this whole cycle of going from code check-in all the way to a successful release of a product all packaged is getting more and more important. And I'd also like to say that even if you're a one-man shop, it obviously makes sense that, you know, you put your code into something like VSTS or GitHub or wherever you want to put it, because it's the obvious thing to do, just to version your own code so you can see what you've done and roll back any mistakes that you did or anything like that. But once you've got it in, say, something like VSTS, it's a very simple step to then start doing this automated build process. So if you're doing mobile DevOps, you should think about this. If you're even a small team, you could think about this, your enterprise developer on ISV, for example. Now, there's some great build examples. So this Parts Unlimited MRP, you can take that and that actually has a lot of integration using open source software. You'll see how it was built. There's actually two versions. There's one originally built for Microsoft Technologies, and there's Parts Unlimited MRP. The MRP is the important part. It uses a lot of open source technologies, and there are a lot of labs available from Microsoft that will help you understand how you can apply DevOps to that specific kind of larger application. And then, of course, Visual Studio Team Services, you can go and try it. It's free for up to 5 users plus kind of unlimited number of MSDN Ultimate users on top. And stakeholders can also come on and track the project without taking up a slot as well. And you get the source control, you get the whole task management system for doing agile and scrum-based methodologies that I didn't show you. And you get the build system and integration to do build definitions, release management. And then, of course, you might want to check out things like Hockey App, very popular for mobile development, and then things like Xamarin Test Cloud if you're doing mobile development as well. So those are some of the great resources available. I hope you've enjoyed this introduction to DevOps or getting started with DevOps. Thank you very much for your time.